Welcome to exercise 6D, where we're going to start dealing with a new concept now on similar figures. So we've been here of congruent figures, and if shapes are congruent, that means that they are identical. They have exactly the same side lengths and exactly the same angles. But if shapes are similar, then that's a little bit different. If shapes are similar, that means that their angles are identical. Their angles match up perfectly. They're equal to each other, but their side lengths are not. So one shape could be twice the other shape, or 5 times bigger, or 10 times bigger. The sides will match according to a proportion or a ratio that creates a thing called a scale factor. So one shape is 2 times bigger, or 10 times bigger, or half as big as another shape based on that scale factor. So all the similar figures that you'll come across, they are the same shape, but they are different in size. So the angles are the same, but the side lengths are in a ratio or a proportion with each other. Now when we talk about similarity, we have a new figure. It's 3 vertical lines, and that means that if we use that, the two shapes are similar to each other. So here's our first example. We've got 2 shapes. Now the question is telling us that those shapes are similar. It says consider the following similar shapes. So we assume that those shapes are similar. So they are exactly the same with the angles. Each of the angles match up perfectly, but the sides aren't quite the same. One shape is a little bit bigger than the other. So the first thing says to write a similarity statement for the 2 shapes. Well, we know they're similar, so a similarity statement would just be something along the lines of shape ABCD is similar to shape EFGH, because we've got our ABCD and our EFGH, so those 2 shapes are similar, and there's our similarity statement. Now if we're going to fill in the boxes, there's a really important thing we need to notice here. E to H comes from this shape, the bigger of the 2 shapes. F to G comes from the bigger of the 2 shapes. So that means we're actually going to be dealing with the big shape compared to the littler shape. So the big shapes on top of these fractions, what sides do they match up with on the little shape is what it's saying. So if we look at side EH, that's the longest side down this big shape. What would it match up with? Well, the longest side on this shape would be 6. So it would match up with 6. Let's look at the F to G. It's the shorter of the 2 sides, vertical sides here. The shorter of the 2 vertical sides doesn't have a side listed, so we'll just call it CD, or you could call it DC, but we'll go for CD. So we've matched in the boxes to match up the sides so that we can figure out the ratios. Let's go to part C. It says find the scale factor. Well, the scale factor is simply going to be a side length on our bigger shape divided by a side length on our smaller shape. We could go back the other way, but the question has started by getting us to go bigger to smaller. Now, a side length on the bigger shape that we know is F to E. It would match up with a side length on the smaller shape that we know of A to D. That's why I chose FE and AD. I just looked to find 2 lengths that we knew that matched with each other. So F to D over A to D becomes 10 over 4, which cancels to 5 over 2, or 2.5 if I want it as a decimal, which means that this shape is 2.5 times larger than the other shape. It's obviously not drawn to scale, but one shape is 2.5 times bigger than the other shape. We go to part D. It says find the value of x. Well, x is a length on the big shape. So what we do is we know the scale factor is equal to the big length that we're looking for. X runs down from E to H and it matches up with A to B, so E to H divided by A to B. What is the scale factor? Well, I found that earlier. It's 2.5. So we can go 2.5 equals x over a to b, which is 6. So a to b gets 6. So 2.5 over 6. 2.5 equals x over 6. I'm going to multiply both sides by 6. 2.5 times 6 will give us an answer of x equals 15 centimetres. So we now know the length of E to H. It's 15 centimetres. E is a bit of a trick question. It says to find the value of y, and you'll notice that y is on the smaller of the two shapes. Well, I know my scale factor is the big shape divided by the smaller shape. So which side does this y, or b to c, match up with? It'll match up with this one here, h to g. So the scale factor will be the gh over the bc. So that over that, which the scale factor we know for this question is 2.5. G to h, or h to g, is 12. B to c is y. So we end up with a statement where y is on the denominator. And you may remember from trigonometry that we can just switch the y and the 2.5 as our shortcut, but times both sides by y, divide by 2.5. It's the same as switching them. And you end up with y equals 12 over 2.5. Do that on your calculator, and you get y equals 4.8. And I probably should have centimetres written on the end of that. Well, there's your example. Remember, with scale factors, once you figured out how much bigger or smaller a shape is than the other shape, that scale factor holds constant for that question. Time for you to try exercise 6D. See how you go. Have fun!